Oh my gosh, what a faux pas. Here I am doing a discussion board on which object has the greater angular acceleration, but I don't ever say, justify your answer. Bah! Well, here we go. It's been interesting. It's probably 50-50 on which one has a greater angular acceleration. So I'm going to just kind of set it up conceptually, go through it, like not even do any math, but just think about it conceptually, and then I'll do some math because we know how much we love using variables and math. But it's easier if we use the numbers we've got. So let me get the screen up, and we'll talk about it. Okay? Oh, there's my toilet paper. Oh, and a little more. Let me close my closet door. I don't know if you've seen my setup. I have it hanging on a knob, right? And then I've got a command hook, kind of keeping it here, and then I've got a force, right? It's an interesting setup, but this is what you do. So is this too close? Let me go back, because I know you want to see me. Whatever. So let's think about this conceptually, right? I've got a force applying, right, a torque, which is going to cause this to accelerate. And so I'm not going to do any numbers yet. And this seems to have the same force, right, applying, right, to this, I guess I called it a solid cylinder, right? But here's the thing. We got to think about inertia, okay? So if we just looked at this, these both have the same rotational inertia. So they have the same resistance to change. So if I applied the same force, right, at 15 newtons, right, I would have the same acceleration. But the question is, did we look at it as a system? I've got rotational inertia here, and I've got translational inertia here. So does that mean that this tension that I'm applying, right, is equal to force of gravity? So I'm going to do just a real quick thing. If we've got a system, I can look at the whole thing, which I don't want to do, or I can look at a part. All right, now I'll look at both parts, right, numerically, but this is just conceptual, and then we'll do some math. If I do this, and this we'll end up using this, my free body diagram has a force tension and a force gravitational, right? Is there translational acceleration? You betcha. And which way? Right? Acceleration is down. So that means force gravity is greater than force tension, which means force gravity is 15. The actual tension, right? The actual tension applied is less than 15 newtons. Okay, so I'm going to stop the video here as far as brief overview of the concept, and then I'll do some numbers. I'll still just have mass the same, but we'll be able to see it doing some numbers and how to approach this in a systematic way. Okay, so let me pause that.